Hey everybody, it's Mr. N here, and we are going to do the next section here in our book, which is we're going to do some proofs with perpendicular lines. So mainly we're going to learn what happens when we do have perpendicular lines. So first of all, let's recall a couple things. We have the corresponding angles postulate. If two parallel lines cut by a transversal, now this is how we abbreviate this whole thing. Two parallel lines cut by a transversal. Then corresponding angles are congruent. Again, that's the abbreviation so that you don't have to write the whole thing out. And now we've got the converse of this. So a lot of the stuff that we're going to do today is actually the converse of the ones that we did in the last section. So the converse of the corresponding angles postulate. Now if you've got two parallel lines that are cut by transversal and the corresponding angles are congruent, then you can tell me the lines are parallel. Here, the lines are parallel. You tell me the corresponding angles are congruent. Here, if the angles are congruent, then the lines are parallel. So let me write that out for you again. So if you've got parallel, then you can say the angles congruent. Here, if you've got the corresponding angles congruent, then that implies the lines are parallel. And I probably should have written this one parallel like this up here as well. All right, anyway, moving on. So this is the parallel postulate, which we talked about, and I'll just say it again. Through a point P not on line L, there's exactly one line parallel to it, and we've talked about this in the previous section. And the converse of the corresponding angles postulate, this is what we use to construct parallel lines. So this is how we make parallel lines, because we're going to make corresponding angles that are congruent. And we'll talk about this in a little bit. And the parallel postulate guarantees that for any line L, you will always construct a parallel line through a point that is not on L. So basically this construction is you've got some sort of line here, and you've got a point not on the line, and you're drawing a line parallel to it, right? That's how we're going to do parallel lines, and we will use corresponding angles to help us do that. Okay, so let's shift this up. And now here's the converse of all the other ones. So the converse of the alternate interior angles theorem. So now you would say if two lines cut by a transversal, so if two lines cut by a transversal and alternate interior angles congruent, then the lines are parallel. Okay, the converse of the alternate exterior. So all of these will start with if two lines cut by a transversal. Okay, so, and then again, we can abbreviate here. I think I may have said parallel here. In this case, these are the parallel ones. So you really should only use this when you're talking about parallel, okay? So over here, if two lines cut by a transversal and alternate exterior angles congruent, then the lines are parallel. All right, let's take a look at the rest of them. Now, you can do these on your own. You may want to pause the video, try to do these. Okay, and then you should have gotten the following. If two lines cut by a transversal and same side interior angles equal 180, then the lines are parallel. If two lines cut by a transversal and same side exterior angles equal 180, then the lines are parallel. And then here's the next theorem. In a plane or two lines perpendicular to the same line are parallel. So if you've got two lines right here, and both of these are perpendicular, you can conclude that these two lines are parallel. All right, and then through a point outside a line, there is exactly one line perpendicular to the given line, and that's like this one up here. I'll use this right here, but now we're doing one perpendicular to it. And then two lines parallel to the third line are parallel to each other. So if this is parallel to this one, and the red one is, we'll say this is a green one here. Okay, so if the blue is parallel to the green and the red is parallel to the green, then the blue is parallel to the red. And then, so here are now the ways that we can show lines are parallel. And this you need to memorize. This you need to make sure you understand. This is how we show lines parallel. We've got the first way is oops. Let's use the pen tool. The first way is to show corresponding angles are congruent. The second way is to show alternate interior or alternate exterior angles are congruent. The third way you can show lines are parallel, show that the same side interior or same side exterior angles are supplementary. The fourth way is to show both lines are perpendicular to a third line. And the fifth way is to show both lines are parallel to a third line. All right. Over here is how we construct parallel lines. Now this construction is a little bit tricky, and I have a whole separate video on this, so you can check that one out on how to construct parallel lines, and that will help you. So I'll save this for that other video. So now let's take a look at, in class we'll do these, but let's take a look at some of these examples right here. The first one is find the values of x that makes j parallel to k. Well, here's j and here's k. We need to know what x is. Well, to make these two lines parallel, here is the transversal. They're on the same side, so that means 75 plus 3x must equal 180 for these two to be parallel. So then 3x equals 105, so x will be 35. All right, on the next one, these are alternate interior. So this is converse of same side interior or consecutive interior. This is the converse of alternate interior. So that means here we need 3x plus 10 to equal 5x minus 10. So you get 2x, and over here 20, so x would be 10. All right, and then on the next one, let's take a look. Again, these are consecutive, so this is the converse of consecutive interior angles. So this means that 6x plus 5x plus 15 must equal to 180. So 11x here would equal 165, which would mean x would be 15. All right, let's take a look at these next ones. Find the value of x and y this time. We've got a couple things going on that make these parallel. All right, so let's start with this one. Over here, you can say this plus this is 180, right, to make these two parallel. We can say, well, but then I'll have an x and a y. So let's see if I do this, alternate interior. These are converse of alternate interior angles. So that would mean 4x minus 18 would equal to 3x plus 2. So x would be 20. And now that I have x as being 20, I could say 5y minus 7 plus this 4x minus 18 equals the 180. And since I know x is 20, I could put that guy in there. So 5y minus 7 plus 4 times 20 is 80, minus 18 equals 180. Let's finish this up over here. So this becomes 100 on that side, minus the plus the 7 plus the 18, which would give me 125. So 5y equals 125, which would mean y is 25. So I've got x, I've got y. All right, let's take a look at the next one. Over here, to get these to be parallel or these to be parallel, these would be converse of alternate interior, right? Because I'm proving parallel, so that's why I'm saying converse. So 5x minus 13 equals 4x plus 5. Over here, x would be 18. Now, these would be corresponding, so converse of corresponding, and that would give me these two lines right here parallel. So that would mean 4x plus 5 equals the 3y minus 1, but I already know what x is, which is 18. So this gives me 4 times the 18, which would be 72, plus 5 equals 3y minus 1. So 77 equals 3y minus 1. 78 equals 3y. So y would be 26. All right. And that's it for now. We will do the other examples, and we'll do more proofs of these. I'll introduce you to some proofs. We'll do that in class. All right, so thanks for watching. Make sure to hit that like and subscribe button, and I'll see you guys in the next video.